session on flexible electronics, trends and challenges. Chairing this session is Mr. A. Gururaj, Director, Smile Electronics. I'd like to welcome him and request him to please come and take his seat on the stage. A brief introduction. Mr. A. Gururaj is currently the Director at Smile Electronics. Gururaj joined Reliance Communications in 2007 as Senior Vice President at Reliance Communications, Mumbai. He has been responsible for manufacturing and ODM relationships at Reliance. He possesses more than a decade of experience in program management, business development, engineering and manufacturing across many sectors. He has authored numerous technical papers and has conducted courses in fiber optics, electromagnetic and electronics circuit at prestigious universities like Stanford in USA. Ladies and gentlemen, I'd like to now hand over the mic to Mr. Gururaj and request him to introduce you to the panel members for this session.
Thank you. Good afternoon. If you're a cricket fan, generally wickets fall after lunch. We'll make sure no wickets fall in this case. It's an honor and a pleasure for me to welcome my panel. I'm honored to say the least. May I request, first, Haim Takra, Vice President, SanDisk, to join us on the stage, please. Krishnan Shrinivasan, Managing Director, Lam Research, India. And Sudhindra Tatti, he is the Chief Operating Officer of the National Center for Flexible Electronics, IIT Kanpur. I'll talk about these gentlemen, give you a brief as a minute before they actually come up with their comments so that what their backgrounds are fresh in your minds. When I look back over the last 10 years of what we've gone through probably in the world, but specifically in India, in 2004, I was in a meeting with the then IT Minister of India. And he had said in that meeting that, look, our vision should be that the poorest people in India should have a cell phone, and that's happened, right? It's amazing. At that time, it looked almost unthinkable, but it's happened, and we know what's happened. The other thing that stands out in my mind over the last, as India has moved forward in the last 10 years, is that I saw a Times of India picture. And in that picture, there was a bullock cart in the front and an advertisement of e-governance in the background. So India is all about bullock carts to e-governance, right? So the diversity and, is so immense. But I think all of us, can't but agree that as a nation, we've moved forward. So coming to this session, I think you all must be wondering what is flexible electronics. So some of you may be familiar, may not be familiar. But this is about we're going to run our imaginations crazy here. I mean, how would you like to see a mobile phone in a curved, shape, or an LCD TV in a shape other than being flat as it is now? So mobile phones offering the value proposition of a mobile phone being its shape, right? Different shapes. So it's interesting, to even kind of think about it now, but maybe it'll happen. And this session is about that aspect, and that is flexible electronics and what does it mean about, what do we foresee, in this space in the coming years. I have with me a very, very distinguished panel, and we're going to start with, Dr. yourself. Dr. Sudhindra Tatti is the Chief Operating Officer of the National Center for Flexible Electronics at IIT Kanpur. He started his career in Motorola Semiconductor as Reliability and Failure Analysis Manager, and later joined Chartered Semiconductor as a Technology Transfer Manager. He's been in various roles as Business Development and Technology Transfer at Amberware Systems, and he's also the founder and Managing Director of Pegasus Semiconductors. Dr. Sudhindra has done his PhD in Material Science from the University of Texas at Austin. On that, once again, in front of everybody, I shake hands because I'm also from University of Texas at Austin. So we are We are fans of the football team, by the way. So, one of the things that we talked about before we came here is that we don't want to give speeches and keep on talking about what we think is, but we would request all of you to participate as actively as you can. We will speak for a few minutes, give our perspective of things, but questions from you, participation from you, interaction with you is what we're looking at. Is that right, sir? So we'll start with Dr. Sudhindra. He has a presentation to make. He will probably explain what this technology is. But when we spoke off stage, I'm going to play the role of a devil's advocate. I'm going to put myself as a man on the streets in Nagpur or Madurai or somewhere and say, what does all this flexible electronics mean to me? What does it mean to me? Can I afford it? What does it mean to me? So that's the role I would like to play here. But all of you feel free, like I said, once we conclude with our initial comments, to ask as many questions as possible. Dr. Sudhindra, please.
Thank you. Good afternoon. Let me jump straight into the presentation. I am representing the center at IIT Kanpur. And what I'm talking about today is flexible electronics, the trends, challenges. And what I will do is, before I get into the actual trends and challenges, I'll take a couple of slides to just talk about what flexible electronics is, just to set the stage so that everybody is familiar. It may be too basic for some of you, but please bear with me. I'll also talk about the applications, the trends, challenges, and then try to end up with several questions on what is really required to move forward. Because the idea here is not to talk about the science, but really catalyze a thought process with ISA, with all the collaborative universities and technical institutes and industries. What is it that we need to do together to make this a reality as we move forward? So first and foremost, let me talk to you about what we at IIT Kanpur Center mean by flexible electronics. There are two keywords. One is flexible, and the other is printable. And the word flexible is what it means, that whatever you can think of today in terms of rigid electronics, if it can be made on a flexible substrate and it can take the shape and form of whatever is the underlying substrate, then that's what flexible electronics means. Equally important word here is the word printable. So one of the things that is going to be differentiating about this technology versus the conventional silicon manufacturing is the way it is made. And so what technologies are used to make these flexible electronics is actually piggybacking on printing technologies. So when you print electronics on a flexible substrate, whether it is paper or glass or plastic, which is foldable, then that's what we are talking about is a flexible electronics. Some of these images are just presented here to give you an idea what we mean by, what is going to come around. And I think we are already seeing the beginnings of applications where instead of rigid electronics, we are taking some actual implementations of flexible electronics. I might add that as a step in between rigid electronics and fully flexible electronics, there is something known as flex hybrid, where only the substrate may be flexible, but the rest of the electronics is still the conventional electronics. And I think we don't want to rule that out because we are not going to jump or leapfrog from rigid to fully flexible without going through this intermediate stage. So one of the key things that I want to mention here is when you talk about semiconductors, when you talk about silicon manufacturing, the first few things that come to mind are a large clean room. So the capital investment for the clean room itself starts with several $100 million, whether it's a class 10 or class 1. The other thing that comes naturally when you talk about semiconductors is very expensive capital intensive equipment. MOCVDs, lithography, etch instruments and all that. So you take another $800 million and you quickly add up and it becomes like $1 billion, $2 billion investment before even you have started making products. Here, in flexible electronics, the new opportunity is actually very exciting because of a couple of things. Number one, it's new materials. So we are not talking about silicon. What we are talking about is this new class of materials called organic semiconductors. So these may be oxides, these may be polymers, these may be non-silicon based. So first thing it does is it takes away our dependence from the silicon world of wafers and clean rooms and all that. So that's number one. Number two is the manufacturing method. We not only do not require like a class 10 or a class 100 type of a clean room, something which is beyond a normal hospital clean room or what we call a pharma class clean room for our understanding is enough for the manufacturing of flexible electronics. And the methods of making it, like I mentioned, we are not dependent on these vacuum-based high-tech equipment. We are going to use printing machines. So that's the, a brief background on what flexible electronics is, why there is so much excitement. We already have a very vibrant industry in India in printing. We have a very vibrant industry in textile manufacturing. We have a chemical industry. And so what we can do here is here's a new opportunity where we can piggyback on these kinds of existing industries in India, adapt it, and maybe make organic semiconductors. And the vision, just to let you all dream about this one day, imagine a newspaper printing press which is printing, newspapers. If instead of the letters, if we start printing electronic layers with our conductive inks and semiconductor inks, then if instead of newspapers, if you can imagine printing solar cells or printing displays or printing electronics, that's the vision of the world that's the journey that we are embarking on here. It may take several years, it may take tens of years, but we at the team at IIT Kanpur, we believe that here's a window of opportunity that we should not miss, because if we miss this, then 10 years from now, we'll again be saying that, well, we missed another revolution. And so this is a starting point for our center, a very core focused group. And I'll talk to you about what the challenges are and what the opportunities are. Let me move into this. I guess the overall vision is you have a fully flexible substrate and you have these sensors and electronics and energy storage and energy generation components, which are all put together on a plastic substrate. So without going into these details, what I want to say is that there are these different components on which research is being done. It's already being done at IIT Kanpur, and it's been going on for past 7-8 years. OLED, I think today morning panel session, we talked about the OLED displays. And displays is a very large thing, not only for TVs and mobiles, but for niche applications also. Energy, photovoltaic, as well as storage, as in flexible PV and flexible batteries. Sensors is a huge thing when we talk about the connectivities with other components and software. Wearables, in terms of the, I think the word conveys a lot what we mean by wearables. And then, of course, the logic and memories and anti-counterfeiting and all. But now, as our chairman asked, all this is fine, all this is okay when we talk about applications. You say consumer electronics, healthcare, automotive, aerospace, energy, and power. I think first question that should come to our mind is, all this is fine for maybe a developed country, maybe it's good. But what is it relevant here for India? So if I take healthcare, then what does healthcare mean in India versus what does healthcare mean in Europe, let's say? If we say energy, then what does it mean for us in India versus what it means for Japan, for example? And so what we did was I could have just thrown a lot of pictures of flexible electronics in each of these areas and said, this is what we are going after. However, that's not what we are doing. What we have done is we have intentionally taken a look from a very Indian perspective. And what we have done is we have cast all those things into the Indian context. And here's the key of everything that I want to emphasize on For example, when we say healthcare, then we are not talking about a very high-tech application for internal drug delivery or for some very fancy high-end application that may be in a hospital in Europe. What we are talking about is the point-of-care diagnostics in India. What are the applications of flexible electronics that can solve Indian problems or Indian challenges? And so what we have done is we have started to approach the Indian industry from the perspective of what India needs rather than what has been done in the West in terms of these flexible electronics applications. Environment, what it means here, air and water pollution is completely different from the other countries. And food processing and packaging. These are all the things which are trends, which are global trends. However, we are trying to look at it in the Indian context of what is the Indian food processing industry, what do they require, what is required by the Indian dairy industry, what is required by the agriculture industry. And when we talk about counterfeiting products, then what is it that we can do to reduce the amount of counterfeiting and all that. So if I can take one or two examples just to talk about healthcare, I mentioned to you that in the developed countries, the meaning of a wearable or a healthcare product may be inside of a football helmet that will be a shock sensor when a football player falls on the ground or something. I don't think that's a product that we want to develop. What we are talking about is, are there applications in addition to the miniaturization and power management which are relevant to our issues? And the first thing that comes to mind is the disease diagnostics. So let me give you an example that may help you to understand that. Today we are all familiar with the glucometer kind of a test where you can do a quick test at home and then take the appropriate medicines based on those results. Our team is right now talking to several people across the country in a series of roundtables, and we are saying, what are the key diseases that we are trying to address, and through what technologies can we address the disease diagnostics based on the Indian conditions, the Indian stigma, the socio-economic situation, and so forth. So a simple a product in mind, let's say, is a wearable product, let's say, but not a very fancy wearable, maybe a textile-based wearable, which can monitor the routine health parameters of the, let's say, the population in the off-grid areas. So these can be temperature sensors, these can be gas sensors, these can be disease diagnostic sensors. So that's an example where I think the global thing of wearables is known, but we are trying to put it into the Indian context and see what are the applications that we can develop. And for that, we are trying to partner with the Indian companies across the country. Flexible sensors, again, all these are possible sensors, but the applications in the Indian context, we are leaving it to the industry on how to go about, whether it's an indoor air quality or a disease detection or food packaging. Spoilage, we all know that food emits a certain types of foul odor or a gas when it gets spoiled. So are there distributed solutions in flexible electronics which we can make it into products which would help to solve these kinds of issues? I covered the air quality problem. Smart packaging is a very big area. I think people around the globe are working on how to not only track and trace packages, but also try to have some color indicators on packages, which would tell you whether the food is still beyond expiry or is it still valid. Also the authentication, whether it's a genuine product or not. There's 30% of the goods today apparently are counterfeit products. And so there is all these little things which we want to take the authentication down to the individual consumer level, who can maybe with his mobile phone just display or read it on a tag on a package and then verify whatever he wants to verify. So So these are the types of technologies that we are working on. And I also mentioned agriculture and dairy. We cannot do anything in Indian context without covering these two areas. So whether it is a humidity sensor or a moisture for soil sensor, or whether it is just temperature, and in dairy, in addition to the animal husbandry part of it, there's also these issues of adulteration and milk quality and all that. So what we're trying to do is come up with very simple diagnostic kits where the flexibility and the form factor of flexible electronics becomes an added advantage, where the rigid electronics, they already exist. We are not saying that silicon has to be replaced. It's just that if there are centralized expensive solutions based on silicon, are there more economical distributed solutions? So that's the game that we are working on. I think these are the trends globally, whether it's personalized health monitoring, personal devices, wearables. I think today morning we talked a lot about the IoT and the energy harvesting and storage and smart packaging. But all of these things, once again, I want to emphasize that we want to do it in the light and the perspective of the Indian context. Again, these are high-end expensive solutions in the West. That's not what we are talking about. We are talking about the applications in the rural areas of India. Now, I think what I'll do now is just, having said that these are all the potential applications and possibilities, I want to cover, in order for all these things to be a reality, what all will it take? Because these are all nice things to be developed, but there are some serious challenges ahead of us in terms of what needs to be done before we make it into a reality. The first and foremost thing is, if you take a mature ecosystem, whether it is silicon or whether it is an IT, you all know that everything is existing in the ecosystem. So you can depend on that supply chain to make it happen. But when we talk about flexible electronics, there is no ecosystem today. Even for research and development, we don't have all the right materials, we don't have all the right equipment and so forth, even for research. Then of course there's a gap of product realization, and then once you take it to production ramp, again there will be supply chain issues. So ecosystem, which is a key component, we need to start planning today so that by the time this thing is a mature technology, this might be, we might be well placed for it. So equipment and materials is certainly something that we have to keep an eye on and a focus on. So what we are doing in parallel is we are talking to the printing industry. And we realize that there is screen printers who are very good at making, screen printing. We have gravure printers. We are, I think, one of the best printing infrastructure in the world, not only for food packages and all that, but also on paper printing. So how can we leverage on that and then help them or help ourselves to maybe transfer them over to the inks manufacturing and inks printing so that this becomes a reality. The overall other challenges that we have, clearly the critical mass for manufacturing, we were talking to several people similar to our centers across the globe, and we were asking them, why hasn't flexible electronics really taken off the way it was predicted about 10 years ago or 5 years ago? Not just in India, but even in the US and Europe, it has not really taken off the way it was supposed to. And one of the key things is that, who's going to be the first guy to invest in the manufacturing of it? So what we now believe is that there can be small applications, but several hundred people, and we can have a centralized sort of a manufacturing to cater to all those people. And I think anybody in the semiconductor industry is very familiar with the whole foundry revolution of the silicon. So something that would be something nice to have in the flexible electronics industry. Awareness of this revolution, I think people have seen some images and some things that are happening, but overall I don't think it has been communicated very well across the country that here we are trying to do this particular aspect of technology development. Innovation, I think no matter what field you take, it will take a collaborative network of institutions and industries. One center alone in Kanpur is not going to be able to do this. So obviously there's going to be a collaborative effort. The industry mindset in terms of what we really, should invest in R&D or not, whether this is investment is good only after it's a mature market, or is it something that we prepare for it now? And of course, talent and manpower to address this new field of flexible electronics. So there are all these questions about make in India, flexible electronics and all, but at the end of the day, you have to ask these questions. Why should we make in India? And if the answers are not correct, then obviously we should not make in India. So we are asking these questions. Is this the right area for us? Having said that, let me just end with an optimistic note that while we are doing the research, the reason for our optimism for this revolution as opposed to the silicon one is that we do have a very good chemical industry, we do have material suppliers, we do have very good printers and manufacturing equipment makers. We can work with the substrates and encapsulants people, and electronic system integration, which has always been a very good forte of the Indian semiconductor community. Can we piece all these together and then create new flexible solutions for the country? I think it's a huge opportunity. It's something that is new, it's a new wave. We seriously believe that we need to do something about it, and we have taken a small baby step in this direction. And we're looking for all the support across the Indian continent, whether it's academic institutions or whether it's industries, whether it's organizations like ISA, whether it is venture firms or whether it is policymakers. So with that note, I think I want to end my note and say thank you very much. Thank you, ISA, for providing the opportunity.
Thank you, sir. I have a few questions, sir, but we'll come back when we have our panel discussion. Coming from our electronics hardware background, one thing I find fascinating in this space, sir, is the material science content, in the electronic space, much higher than in the conventional printed circuit board kind of technology, but we'll come to that. One point I wanted to make to the audience is all four of us backstage talked about vision, right? And all of us said it's about vision and passion. And recently I saw a writing, it was a statement made by Azim Premji. He said that if people don't laugh at your vision, it's not big enough. So we got to make sure all of us laugh at us, sir. So I think there are very experienced people here, and I think the vision is big. And when we come to the panel discussion, we'll get down to, at least I'll try to get down to what it means, in terms of products and cost and some of those practical realities. Our next speaker, not making a presentation, is Hem Takiari. He's the Vice President of Packaging and Assembly Engineering at Western Digital SanDisk, where he manages development teams worldwide spanning over 6 countries, covering semiconductor and electronics products for retail, OEM, and enterprise world. At Western Digital or SanDisk, he has been instrumental in setting up greenfield assembly and test operations in Shanghai, as well as now in Penang, including extensive assessments such as factory options in other parts of the world, including India. In one of his prior roles at SanDisk, Hem was responsible for setting up a corporate quality and reliability function spanning over 6 countries. With more than 35 years of experience in semiconductor assembly and device packaging, Hem has been refining the manufacturing processes, systems, and procedures to drive aggressive quality and cost goals. He has been a key player in driving the adoption of micro SD standards at SD Card Association. Over to you, sir.
Okay, so what a great opportunity in front of us. New technology, new set of products, incredible possibilities for innovation. So thought I'll walk you through a case study that I have lived in my life years. Similar opportunities several years ago, it's been almost, I think, 12 years, and the case study is that of a micro SD development where the technology was very new, material sets were very new, the tool sets didn't exist, the market wasn't there, and all we had was a customer with few discussions to create a vision. So what I'd like to share with you is a story of what it takes to take a brand new technology, brand new set of products, how do you take it all the way through manufacturing to a great success? So microSD is a good example to look at, which almost didn't exist about 12 years ago. And the rate at which it is growing, I think there will be one microSD for just about everybody on planet Earth by year 2020. So that's how popular that product has been. So when the product was conceived, we had no idea how to build it. The tool sets were not there. So it's a story about vision, passion, execution, but more than that, it's shared success. And its shared success comes from shared vision, shared passion, and shared execution. I think those are very important elements. In case of microSD, I'll share with you what are the things we did which made it successful, and from there you can infer if we did not do that, how far we could have gone. So part of the shared vision is really a customer defining the requirement and then expanding from the vision, which is really going to a wider range of customers and getting their buy-in into that vision and get behind one shared vision. And in this case, the shared vision turned out to be is how do you bring fairly cost-effective storage to those people who need it and when they need it. So in handset, yes, it's easy to embed the storage, but getting it to the users who need it and when they need it and how much they need it. That was truly the revolution that made the product successful. We did not start with that vision. This was a shared vision which got developed through the discussions with the customers. So that's one key message. How does one evolve with a compelling vision? And a compelling vision has to come from your engagement with the customers. Of course, you have to look at all the possibilities from the technology point of view, what's possible to do. But once you have gone that far, how do you bring all the technology elements together? And that's where the partnerships come in the picture here, and standards. Part of bringing up standards is the shared vision that you have, that you're willing to share that with your manufacturing partners as well as customers, but more important, competitors as well. Because in this big game, if you want to succeed, I think you need to make sure the ecosystem is cost competitive. And for ecosystem to be cost competitive, the market opportunity needs to be fairly large. So in case of microSD, the tool sets which had to be developed, and each one of these tool sets for building this product, they cost several $1 million. And clearly, if the market was not big enough, our manufacturing partners would not have moved forward with us to develop these expensive tool sets and make the commitment. So I truly believe what the tool set suppliers did for us had a huge impact in making this a success. That's an important point to recognize. We would not have been successful without the tool set partners there. Standards. And here's a product that you think you have conceived, and you have a good idea how you're going to manufacture. You have the tool set suppliers lined up. So why not just go it alone? Why not? Why do I want to share with others? But a decision that we do want to share, and we want to help competitors also understand how to manufacture this product, had a tremendous impact. I mean, I couldn't have imagined 12 years ago that we would be shipping 256 gigabyte storage capacity in this small form factor. And I really think that's a result of sharing the success with our competitors, which drove that whole market. And it has taken, I mean, it truly has changed the landscape of portable electronics. So I can share a few examples what it means to flexible and hybrid microelectronics. I'm going to get some water here. So I think you heard quite a bit yesterday, hardware for free. That's an extreme viewpoint, but somewhere in between is relentless passion to drive the cost. And I think the opportunity that is there for printed and flexible hybrid microelectronics, I truly believe it's how one looks at all the tool sets ranging from MOCVD and evaporation, the fab-like processes. And on the other hand, the examples which are put forward, such as printing, and there's a very, very wide range of technologies for printing which can deliver accuracies anywhere from 5 micron to hundreds of micron. So that whole spectrum, I truly believe one key element to success here is going to be somebody who looks at the whole cross-section of the tool sets and the processes and figures out what is the most optimized cost solution that you can bring to the industry. And that will really help to bring the cost down and bring the competitiveness in the market. And that is leading to the adoption there. So with that, I think I'll sum up my comments here.
Thank you, sir. We talked about free hardware. I think I have a question for Josh, the MD of Foxconn, in the next session on free hardware. For those of you who get on the stage ever at an ESA event, there's a huge big screen here with font size, I think 150, which shows you how much time you have left, and we don't have too much time left. So I'm just going to request Krishnan Shrinivasan to provide his comments. He's the Managing Director of LAMP Research India. In this role, he is responsible for leveraging LAMP's capabilities in India and driving the organization through another phase of growth. Mr. Srinivasan first joined LAMP in 1995 as a senior mechanical engineer and made his way through the ranks to become a senior director of systems engineering, where he headed the LAMP India Global Hardware Technologies. He began his career as an instruments manager with Serata Geomechanics in Richmond, California, before moving to Alameda, where he worked for 5 years as a systems engineer. Krishnan then worked at Synthetica Technologies, also in Richmond, before co-founding Dextra Systems in 1993 in Berkeley, providing his expertise in electrochemical consulting, reactor design, and system integration. Very importantly, Krishnan has 19 patents and has presented at various symposia and conferences. And when we talked backstage, he talked about the need to actually get a product out of everything that you can possibly conceive, right? Sir, over to you, please.
So, over the last 2 days, I think a number of people have made a bunch of different points, and I think we should spend a little time tying all these threads together in the little time that we have left. One point that was made yesterday was that India is very strong in design, but may have missed a number of buses in terms of manufacturing. And Dr. Sudhindra made mention of the fact that we missed the whole semiconductor revolution. The second point that was made is that India is a vast consuming nation, that we have a vast population of consumers for all sorts of different technologies. Just to take an example that Dr. Sudhindra mentioned, medical devices. Within this one country, we have represented all the full range of human diseases, ranging from the diseases of deprivation all the way to the diseases of affluence. And so it's an enormous market for medical instrumentation. Another point that was made was that even though we got a good head start in silicon-based semiconductor technologies, we have missed the revolution that's taken place over the last 3 or 4 decades in that area also. And one of the nice things about the human experience is that you get repeated opportunities to do something revolutionary. And I think to the extent what was presented by Dr. Sudhindra a few minutes ago represents this opportunity that we should be looking at and taking in terms of flexible electronics. And for that, I think the most critical disadvantage that we've had here in India is the inability of our ecosystem to productize research and scientific development. Our universities are very good at putting out cutting-edge research and materials and technologies, but our industry-academia interaction has not been very efficient. And so that would be, to me, the primary opportunity that we have here in terms of flexible electronics. Just to give an example, we are now beginning to construct an ecosystem of ESDM. I think over the last 2 days, we've heard many mentions of Foxconn, Apple, and other handset makers who are setting up big assembly plants in India. And as those assembly plants spin off an ecosystem of suppliers, there probably is an opportunity for someone like yourself to begin to figure out an intersection point into that supply chain, into that value chain for your technologies. And that may be something that we could discuss as part of this panel discussion and the question answer session going forward.
Thank you, thank you. I have a few questions, but I'm going to wait because I think we should throw the floor, we should have you ask questions first and then come back to what, if we have time, to what I may have. So we throw the floor open. Please come up with as many questions as you can so that we make this truly interactive and interesting. Okay. There's Som. Som, you're going to have a difficult question.
So, Professor, great presentation. It gave us a good overview about where things are with flexible electronics. So I wanted to quickly ask you, especially about the air quality, the gas sensors and so forth. At what stage of research are these in? We are in dire need of air quality sensors today in India, water quality and air quality. Today, if I want to import these sensors out from other parts, it's very expensive. So where are we at? Are we looking at 10 years hence? Are we looking at 3 years hence or 5 years hence?
Well, thanks for the question, because sensors is a very important aspect of development at our center. Amongst the different types of sensors, they are all at different stages. So I would say that the temperature sensors are actually quite a bit advanced now with our polymer-based temperature sensors. Gas sensors are next. And then there are biosensors, which are, we have done a lot of good prototyping work, but we need to productize it. One of the things that we at our center have always said is we will take our research to fundamental research level, but actually for productization, we will partner with the industry player. And so in some cases, like the gas sensors, we are now in the MOU stages with industry partners who have a requirement for that flexible gas sensor, and then our time starts clicking. So in terms of where we are, I think we are in the matter of years, as in like couple of years, 2 years, 3 years kind of time frame. It's not at such basic research that will take another 7 years to figure out what the chemistries are and all that. Having said that, there are some which are ready for immediate prototyping, like temperature sensors I mentioned. And over the last year when we are doing roundtables, what we are doing is we are trying to benchmark today's solutions. Like you mentioned, there are imported sensors which are giving solutions. What do we need to do? Because cost is obviously going to be a factor. So in terms of prototyping, I think we'll be able to do it in fairly short term, but the long-term objective of cost will require the overall ecosystem and manufacturing and all that. So different stages, but it's a matter of years, not decades.
I had a question. I don't know if any of you three would. Has any analysis been done, sir, of all of us, many of us in the audience have seen so many products being designed in India, but I don't know if I'm wrong, but I don't know if too many even mobile chargers sold in India are designed in India. That's one of my regrets. Maybe there are some, but I don't know. I don't know. But has any analysis been done of, for example, what the investments would be, the return on investment? Because end of the day, somebody will have to put in money into this, process of it being, productionized, and he will look at the returns. So, any comments on what you think the viability of the business model is at this point of time in this technology?
I don't think there's an analysis done, but if we go by the reality of the market, people always say it's cheaper to trade than to make in India. And that's the bottom line, seems to be the standard answer. And so there is no first takers in terms of trying to make something. Having said that, I don't think that needs to be that way. I think there is enough, the industry in India wants almost like a surety of making their returns on investments and so forth. And I think some of this has to change in terms of investing upfront in some technologies that actually may or may not see the market. So every time I mention that we missed the semiconductor bus, at the end of the talk somebody will always come and say, oh, that's just semiconductors. We just missed the biometrics bus. We missed this RFID bus. We missed the NFC bus. We missed the charger bus. And so I think one thing that what we want to do is, can we stop missing buses and start to do something about it? Having said that, there's also an opposite quote from Richard Branson on my calendar that says, opportunities are like buses. There's always one next one coming. So we hope that that's the case.
I mean, I just had one question for you. The gentleman asked a question about sensors, and I understand that it's easier to trade than it is to make, and that cost then becomes a big issue. But has your center looked at areas in which your technology enables something that cannot otherwise be enabled by traditional technologies, whether it's enabling by way of cost or performance? Has that been looked at?
All right, in our case, actually the reason we are optimistic about cost is because, like I mentioned, we are going to piggyback quite a bit on the printing type of industry, which already exists in India. We don't have to invent the printing industry in India. We don't have to invent MOCVDs and clean rooms and all that. We have a vibrant chemical industry. People know how to make molecules. So there's a bit of good chemical engineering, chemistry, physics, So I think there are more reasons for optimism and cost trajectories in our case. But that's the eternal optimist that I am, but we need to benchmark it for sure.
Sir, two things. One is you talked about opportunities being like buses. Mahendra Singh Dhoni says that opportunities are like heartbeat. You can't afford to miss a single one. And I'd like to go with the Mahendra Singh Dhoni philosophy, right? And my second point is that many of us have seen this ad on TV where a guy is buying a yacht. He's fancily dressed, And in India, it's all over. Then after buying that yacht, which probably costs crores of rupees, he says, mileage kitna deti hai? Right, so kitna deti hai? Now, in this kitna deti hai thing, sir, have we done any analysis, or any of us here, my panelists, SanDisk, like, Hem said during his talk, even, probably when you started off, on that count, I was talking to my driver. He has 4 memory sticks with him. And he said, what are you doing with 4? One Malayalam, Kannada, Hindi, English songs, right? And he keeps switching it around. So obviously you've met that cost pressure of the Indian customer, right? And it's evolved to a point where you make it affordable. So what do you foresee on the cost perspective?
Yeah, again, like I said, passion. So cost, driving the cost when it comes to manufacturing has to be your passion. And the best way you have to look at is, what does the technology allow you to achieve? And figure out how to achieve that. And do that better than anybody else in the industry. And that's really, if you keep that goal in mind, that's what's going to make you successful.
Anything, Krishnan, you want to say on the comment on the cost aspect? Do you have any comments?
Well, my experience in cost comes from the semiconductor industry, which I think everyone's aware of the Moore's law. The benefit of Moore's law in this industry has been to drive down the cost of semiconductors by orders and orders of magnitude, to the point where the use of semiconductors has become democratized. Almost everyone carries in their pockets vast amount of semiconductor content that is possible mainly because costs have been driven down. So just going back to the missing of buses, this represents, I think, flexible electronics, to my mind, represents an opportunity for us to leapfrog also. If we have missed a semiconductor bus, there is a leapfrogging opportunity available here, which may hit the sweet spot for us in the value, difficulty, the intersection between value and difficulty. And that's something I'd maybe like you to comment on is, you've said that it's easy to do these with printing presses and chemical industries that we already have in place. What industry partners have you reached out to, and how are you looking at intersecting the supply chain or value chain with the technologies that you're developing at IIT Kanpur?
So in addition to, or in parallel to the research work that is done by the faculty teams, part of my job has been to reach out to the Indian industry through a series of roundtables, through individual interactions, through these kinds of workshops over the years. And we have got traction from the packaging and printing industry in a very decent way, simply because if you think about screen printers, for example, they have reached a level of saturation, they are frustrated about costs, and now they are looking for a new opportunity. Similarly with the other types of printing players. And so for them also it's an opportunity to maybe participate in a new revolution. So we have partners on the equipment side, we have partners on the printing and packaging side. Our equipment partners actually are not only Indian players, but actually the global players, UK, US, and Japanese players. So we have done what I would call the preliminary first steps, but we have a long way to go, and that's where we are seeking for continued support from a lot of these partners.
Yeah. So Professor, this is a question for you. How can bodies like the IESA help expedite research that's going on? How can we accelerate it? Is there any part we can play?
First of all, just a quick clarification or disclosure. I am not a professor. I joined this center without any academic background, and I'm not teaching there at all. So I'm fully dedicated to the center for the sake of commercialization of these technologies and all that. So that's just true. But it highlights the fact that we are focused on the industry side rather than being a purely academic research. Coming back to your question about what can ISA do, of course we are looking at organizations like ISA from the simplest things like conducting workshops, introducing us to the startups, introducing us to the industry partners, helping us with the, the awareness creation that there is something like this that exists. Many people didn't know that there was a center at IIT Kanpur. People were traveling all over the globe for technology transfers in printed electronics. And in Europe, somebody said that, well, go to Kanpur, there is a group working there. So I think there is a little bit of all of these things that can be done. Collaborative work, which I'm talking about, with not only academic institutions, but also with the industries, is a key thing that you can help us out with. Another very simple observation over the last year as I've been trying to reach out to the industry is, very interestingly, the big players are not interested right now. It's only the hungry, passionate, small players who are very keen to do something in this space. So in that sense, the startups and the SMEs are a very, very good opportunity for us to team up with them.
If there are no more questions, I think I just want to go back to my, that thing, ever since I've read it, it's inspired me immensely, and that is Azim Premji's statement. I'm just going to repeat it, and he said that if your vision is, if people don't laugh at your vision, it's not big enough. I think people they may be skeptics, there may be a lot of people about emerging technologies, there always are, and I do believe that coming from this space, the electronic space, I believe that there will be probably a day when they may seem laughable. We'll have all kinds of shapes of mobile phones, all kinds of shapes of TVs, and let's see what the future holds. So on that count, thank you everybody for being here. Thank you, all the three gentlemen for providing us your time. And finally, let me tell you, like airline captain, we've reached 1 minute and 26 seconds in advance. Thank you for your time.
We'd like to thank the panel members. I'd like to request Mr. A. Gururaj to present a small token of appreciation to our three panelists. I'd like to thank Mr. Him Takiari. I'd like to thank Krishnan Shrinivasan. And we'd like to thank Dr. Sudhindra Thakur. I'd like to request Mr. Sompal Chaudhary to IESA Executive Council to present a small token of appreciation to Mr. A. Gururaj for chairing this session. I'd like to request Mr. Sompal Chaudhary, IESA Executive Council, to present a token of appreciation to Mr. A. Gururaj. I'd like to thank you, sir, for chairing the session, and we'd like to thank all the panel members for that very interactive panel discussion.